Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. May all the peace and blessings of the Almighty Allah subhanahu wa ta'ala be on all of us. Now today, as you can see, I want us to dive and navigate through the factors affecting preferential discharge during electrolysis. Now there are three factors that affect the preferential discharge. Number one, you have the position in the electrochemical series of the anion as well as the cation. Here we have a section of the cations, the positively charged elements, and here we have the anions, the negatively charged element. Now let's look one by one. We have from potassium to silver. This one is the least readily discharged, and while silver is the most readily discharged in the part of the cation. And in the part of the anion, we have the most readily discharged as hydroxide and the least readily discharged as the fluorine. Now class, I want us to look at number 2, which is concentration of electrolyte. And number 3, the nature of the electrode used will determine the product that will be obtained at the electrode, the product that will be obtained at that electrode. Good. Now let's look one by one. Number 1, position in the electrochemical series. Now let's look in the electrolysis of dilute sodium chloride. Number A, sodium chloride. In sodium chloride we have cations, we also have anions. The cations in sodium chloride we have sodium and we also have hydrogen. The anions you have chloride, you also have hydroxide. One very basic thing that you need to understand is that when it is dilute, we must be having our solvent as water. And when our solvent is water, automatically we must be having a cation as hydrogen and one anion as the hydroxide. Now from there, which one will migrate to which electrode is the next thing that you need to understand. From there now, these one are the cations, the positively charged ions. They will migrate to the negatively charged electrode, which is the cathode. Now these two will migrate to the cathode. Migrate to the cathode. Now when the sodium and hydrogen ions, which are positively charged and are termed as and are referred to as the cations, migrate to the negative electrode, that is the cathode, which one will be preferentially discharged. Now in our electrochemical series, we can see that hydrogen and sodium, which one is preferably discharged instead of the other. Now we can see that hydrogen is preferably discharged, or rather hydrogen has higher tendency of gaining electrons as compared to sodium, and therefore we can get hydrogen ions becoming hydrogen gas plus electron. That is it. On the other hand, this is the cathode. What about the anode? We're going to balance after finishing up the equation. Now you can see we can put 2 here 2 as well. We have 2 hydrogen ions, 2 hydrogen atoms, 2 electrons. Now let's go to the anode. In the anode, these one too will go to the anode. Anode is the positive electron, and this one are the negatively charged element, which are referred to as the anions. Now when chloride and hydroxide go to the anode, which one will be preferentially discharged? Hydroxide is going to be preferentially discharged. Hydroxide is going to be preferentially discharged. And when hydroxide is preferentially discharged, what will be formed? Plus electrons. Sorry. This one hydrogen ions plus electron to form hydrogen gas. From there we can balance 2 and 2. Now at the anode we have the hydroxide preferential discharging to form water plus oxygen gas plus electron. Now we can see that we have two oxygen gas plus 1, 3, hydrogen 2. Now how can we balance? We can balance it by placing 2 here. Now we can get, we have 4 hydrogen atoms. Now on balancing here we can place 4 hydrogen. Balance this, 4 hydrogen, 4 oxygen. 4 hydrogen, oxygen 4, electron 4. Now we can place the electron 4. Now we come back to our cathode again. Now that this has lost 4 electrons, therefore this must also gain the 4 electrons lost by the hydroxide. And therefore this one now becomes 4. This one becomes 4 and this one becomes 2 hydrogen atoms that will gain 4 electrons to 4 hydrogen ions that will gain 4 electrons to form 2 molecules of hydrogen. H2 is one molecule, and when there are 2, this is what will be formed. Now let me write the state simple. AQ as gas, AQ liquid gas, and that is the whatever that will happen at the cathode as well as the anode. The cathode is the positive electrode, while the anode is the negative electrode. Sorry, the cathode is the negative electrode, while the anode is the positive electrode. Now let's look at what will happen when concentrated sodium chloride, sometimes being referred to as the brine, is electrolyzed, and what will move to where and which one will be discharged preferentially instead of the other, and what is the reason to that. Now this one was dilute. Let's go to the next one. Conc, brine. Now when we hydrolyze when we electrolyze concentrated sodium chloride, the following will move to the cathode. Cathode, we have sodium, we have hydrogen. Anode, the positive electrode, we have hydroxide, we also have chloride. Now in this one, hydrogen and sodium, again hydrogen will be preferentially discharged. Hydrogen ions plus electrons to form hydrogen gas, and balancing we're going to get 4 and 2 gas AQ. Now what will happen to the anode? Despite the high concentration of sodium ions, instead the hydrogen ions has higher tendency to gain electron as compared to the sodium despite its high concentration. But on the other hand, at the anode, the hydroxide and the chloride will be preferentially discharged instead of the hydroxide, principally because of the high concentration of the chloride. We come here again, you have chloride, chlorine gas plus electron forming 2, and that is it. Now we can see, class, that in this case we have seen that the hydroxide ions lost 4 electrons, and that is why we require 4 hydrogen ions to gain the 4 electrons to produce 2 moles of hydrogen gas. In this case now, the chloride ions will be preferentially discharged, and when the chloride ions will be preferentially discharged, they are going to lose 2 electrons. Now the 2 electrons lost must be gained by hydrogen. That is why we need 2 hydrogen ions to gain the 2 electrons lost by chlorine, and that is why in this one we have 2 hydrogen ions, 2 moles of hydrogen ions, and here we have 4 moles of hydrogen ions. It is dependent on the number of electrons lost at the anode, so that we can balance this scenario. Pay attention. We have hydroxide losing 4 electrons, and for us hydrogen, we have each hydrogen gains 1 electron, and therefore for the 4 electrons lost by the hydroxide to be absorbed, to be gained by hydrogen, we require 4 moles of hydrogen ions to gain the 4 electrons lost, and therefore, and finally we are going to form 2 moles of hydrogen gas, and that is the difference when we have dilute sodium chloride and we have concentrated sodium chloride. Now next, dilute sulfuric 6 acid. Dilute sulfuric 6 acid. Now let's look at what happens when dilute sulfuric 6 acid is electrolyzed. What will happen when dilute sulfuric 6 acid is electrolyzed? Now we can use this one again. Dilute sulfuric 6 acid is electrolyzed. Now we can see that we have cathode and we have our sulfuric 6 acid. Our cathode will be having hydrogen, anode. In our anode we will be having sulfate, we will also be having hydroxide. But again, because we have hydrogen, in both cases we will be having hydrogen and the sulfate. Now in this case, which one will be there is no even need for you to speak about the preferential listing because you have the same cations at the cathode. You have hydrogen plus the electron to form hydrogen gas. Now we see which one will discharge preferentially instead of others. Automatically is the hydroxide. The hydroxide is going to preferentially discharged. Water plus oxygen plus the electrons. Now on balancing, we're going to get we are going to form 4 electrons. Now there are 4 electrons lost by the hydroxide. That means we need 4 moles of hydrogen atoms to gain the 4 electrons lost, and therefore we need to form 2 moles of hydrogen gas, and that is it. Now from there we can go to aqueous magnesium sulfate. Aqueous magnesium sulfate. Let's see what will be formed when aqueous magnesium sulfate is electrolyzed. Now magnesium sulfate, aqueous magnesium sulfate. Now we have cathode. In our cathode we will be having magnesium. We will also be having hydrogen. On our cathode we will be having hydroxide as always. We will also be having the sulfate. Automatically here we can see hydrogen will be preferentially discharged. Hydrogen plus electron to form hydrogen gas. That is 2. In this case, hydroxide will be preferentially discharged, and that is hydroxide form water plus oxygen plus electrons. Now on balancing, you can see we need to have that is 4. We need to have 4. Now we need 4 electrons to be gained by hydrogen, and therefore we require 4 moles of hydrogen to gain the 4 electrons lost by the hydroxide. We need to form 2 moles of hydrogen for complete reaction. Very good. And that is AQ gas, AQ liquid gas, AQ gas, and this is AQ liquid gas. And that is briefly about the 4. Obvious thing we can see is that on the cathode we must be having hydrogen ions, and on the cathode we must be having hydroxide ions. And there is only one scenario. This one is on the anode. Hydroxide ions will always be preferentially discharged, except in scenarios where we have highly concentrated brine. Let's continue. Electrolysis of copper to sulfate solution using carbon electron as well. Sometimes platinum can be used. Now what will happen? What will happen when those things are used as the electrolysis? Now let's discuss number 1. Copper 2 sulfate. Copper 2 sulfate, carbon electrodes. Now we have our anode. We also have our cathode. Our anode class, we will be having hydroxide. We will also be having the sulfate. Now, automatically, we know the hydroxide will preferentially discharge to form water plus oxygen plus electrons. Now, on balancing, we can see it's automatic. We require 4, 4, 2. Now, what about on the anode? We have on the cathode we have copper. We also have hydrogen. Now we can clearly see that copper has higher tendency to gain electrons as compared to hydrogen, depending on the electrochemical position on the electrochemical series. They're going to form copper, 2 electrons plus electrons to form copper solid. You have 2 copper electrons. Now class, this one has lost 4. Therefore, we need 2 copper ions gaining 4 electrons, forming 2 copper atoms, which is the product. And that is what will happen. Now, what will happen to the color of the solution? We know copper 2 sulfate solution is blue in color. Now, as the electrolysis process continues, what will happen to the blue color of copper 2 sulfate? The blue color of copper 2 sulfate fades, or the color becomes pale, showing that these ions are undergo reduction and they form copper solid. And this copper solid is deposited at the cathode, and that is why we say the mass of the cathode increases and the solution becomes pale. Number 1, the mass of the cathode increases. Number 2, the solution becomes pale. Good. Let's continue. Lastly, I want us to discuss the electrolysis of copper 2 sulfate using the copper 2 sulfate, copper 2 sulfate, copper 2 sulfate, copper electrodes, copper electrodes. Now, we have anode, we have cathode. At the anode, we will be having hydroxide, we will also be having the sulfate. At the cathode, we will be having hydrogen, we will also be having the copper. Now, at the anode, none of the hydroxide and the sulfate will be discharged. Instead, the copper ions, the copper electrode or the copper anode undergoes oxidation and enters into the solution as copper 2 ions. Very key point. Both the hydroxide and the sulfate, they move to the anode, the positive electrode, and none of them gets discharged. Instead, the copper anode undergoes oxidation. Instead, the copper anode undergoes oxidation and enters the solution in form of copper 2 ions. Now, look, we have copper 2 copper electrode becoming copper solid, copper 2 ion. This is copper solid, copper 2 ions plus 2 electrons. Now, what happens at the cathode? At the cathode, we have copper and hydrogen. So which one will be preferentially discharged? Automatically it will be copper. Now, copper 2 ions plus 2 electrons to form copper solid. This is aqueous. Now class, this is a very important thing that you need to understand. At the anode, we can see the copper solid undergoing oxidation to form copper 2 ions. On the other hand, we can see at the cathode, copper 2 ions undergoing reduction to form copper solid. Number 1, the first thing you need to understand is the color of the solution, does not change. Does not change. Why? Because the copper 2 ions that undergo reduction is being replaced by the copper anode, which goes into the solution in form of ion, and therefore there is a balance of charges. As the copper ions is reduced, undergoes reduction at the cathode, we also have copper anode undergoing oxidation from the anode, and therefore there is a balance of charges. Number 2, that is why the blue color of the copper solution remains to be blue. Number 2 is, now that hydrogen ions are not preferentially discharged, that means what happens to the nature of the solution? The solution tends to be acidic. The solution becomes acidic. The solution becomes acidic. Very important point. The copper anode, which is the anode, undergoes oxidation and enters into the solution as copper 2 ions. Now, at the other electrode, which is the cathode, copper undergoes reduction and is deposited on the at the cathode. What happens? The mass of the cathode increases. Mass of cathode increases. Mass of anode decreases. Mass of anode decreases. You can see that the mass here is going to decrease while the mass here is going to increase. Why? The copper solid now is deposited as a red coating at the cathode, at the electrode, that is the cathode. And therefore, this is a very important observation that a learner is supposed to be making. Number 1, that when copper 2 sulfate solution is electrolyzed using copper electrodes, what happens? Which one is going to migrate to which electrode? That is a basic fundamental key. Now, we are going to see that the hydroxide and the sulfate are going to migrate to the anode, while the hydrogen and the copper is going to migrate to the cathode. Good. Now, at the electrode called the anode, none of the hydroxide, neither the hydroxide nor the sulfate is going to get discharged. Instead, the copper anode gets oxidized or undergoes oxidation and enters into the solution as copper 2 ions. Now, therefore, that the copper anode is now undergoing oxidation and entering into the solution in form of ions, that now translates to us that the mass at the anode is going to decrease. But again, on the cathode, the mass of the cathode increases. Why? Because the copper 2 ions and the hydrogen ions migrated to the cathode. Because the copper 2 ions have higher tendency of gaining electron, or rather is more readily discharged as compared to hydrogen, based on the electrochemical series, is going to undergo reduction and is going to form copper solid that gets deposited as a red coating on the cathode, therefore explaining the mass increase at the cathode. Now that the hydrogen ions is there and has not undergone any discharge, therefore that means the solution is now going to become acidic. That is observation number 3. And the last observation again is, what will happen to the color of the solution? The color of the solution remains to be blue. Why? Because there is a balance of charges. As the copper 2 ions which were in the solution undergoes reduction at the cathode, we have copper anode that is going into the solution in form of copper 2 ions by undergoing oxidation. And therefore, that is briefly about electrolysis of copper 2 sulfate solution using copper electrode. And that is the end of our lesson. Always be determined, have dignity, and do things with distinction that is widely admired by the society. Thank you very much. Have a blessed day.